Okay, Ahava, we are now to section, or Isaac, whichever the case may be. We are now to section 11.6. These are the materials that I'm using currently. We still have the blue highlighter just in case, the yellow highlighter for all the definitions you're going to have memorized, and the ink pen of some sort. Mine chooses to be blue today. Who pulled the pink one? I'm just saying. And keep these out here to the side. We're starting to talk about circumference in this lesson. And so the first thing we're going to talk about is the circumference, or the definition of circumference, and it's the distance around the circle. Sorry. The distance around the circle, or the circumference of the circle, because that's what it is. And then when you turn the page, Theorem 11.6 says for all circles the ratio of the circumference to the length of the diameter is the same. In other words, that ratio is pi, or 3.14 ... because it keeps on going. But they can use that it's the same like they did in this example, which isn't exactly excruciatingly important. Pi is an irrational number. I guess you need to know what the symbol looks like, but you've used it before, so I'm not too worried. It is approximately this and can be used as 22/7 also. The circumference of any two circles have the same ratio as their radii. That's because it's pi. And if C is the circumference of a circle with a diameter of length D and a radius of length R, then there are two different ways that you can find circumference. You can either use the diameter and multiply it times pi, or you could say 2 times pi times R, not pi r squared. The 2's in the front now, so it's just a regular 2 times. Okay. All that is stuff I expect you to have already seen and know before. Up here at the top of the next page, it talks about arc length. And arc length is a portion of the circumference of the circle. The degree measure of the arc divided by 360 gives the fractional part of the circle that the arc represents. In a circle, the ratio of length L of an arc to the circumference C equals the ratio of the degree measure of the arc to 360, which means that the length of the arc is going to equal m divided by 360 times 2 pi r. That's the one I want you to deal with, not this one. What that means is when you're over here, you have circle T with radius r, ta-da, has arc AB with a length L. If the diameter of T is 24 inches, that makes our radius 12 inches. The measure of arc AB is 60 degrees. Find L. So they said L is equal to 60 divided by 360, because the M was 60. That's the measure of your angle. Times 2 times pi times r. And so the 2 times the r gives you the 24. And then there's pi. 60 times 24 divided by 360 is 4 pi inches. Do you see how they left it in terms of pi? In other words, there's a pi in your answer. Some of these, you're going to be expected to leave them in terms of pi. The only time you ever multiply by 3.14 or by 22/7 is when they tell you you're supposed to. If they don't tell you, you leave pi in your answer, just like you would leave an X in your answer, because it's the same kind of thing. It's just we happen to know what this X equals. So if they tell you which one to use, then you use that one. If they don't tell you which one to use, you leave it in terms of pi. Okay. Is it possible to have a circumference exactly 6 inches and a diameter exactly 2 inches? I'm not worried about that. Moving on. Supposed to work example 1 and example 2. I just did example 2. Going back here, this is example 1, but I'm saying you know how to do this. If R is 5, find D. D is going to be 10, and C, which is circumference, which is 2 times pi times R. So let me grab a pen so I can work it out. So for A, circumference is equal to 2 pi times R. We just said my R was 5, so that's going to be 10 pi. And since they didn't tell me in the directions what pi was supposed to equal, we leave it in terms of pi. Look, I was right. For B, if the diameter is 10, since they told me the diameter, I'm going to use this one. If they tell you the radius, you use that one. So since they told me the diameter, I'm going to use this one. Pi times the diameter they said was 10. They want you to find C. Then they said use 3.14 for pi. So C is going to equal 3.14 times 10. So C equals 31.4 inches. Look at that. Then they said if radius is equal to that, find C, use 22 over 7. Are you worried about fractions? We'll find out. So C is equal to, they gave me radius, so that's going to be 2. I can go ahead and put my 14 first, because it doesn't matter, since it's multiplication, what order they go in. So 2 times 14 times 22 over 7. If you'll look, I can cancel out some stuff. So I can say that 14 has a 7 in it, and that'll cancel out with that 7. So that'll give me a 2 left on top and a 1 left on the bottom. So now I have C equals 2 times 2 times 22. 4 times 22 is 88 inches. We're not talking about area, so nothing gets squared. And then if C equals 28 pi, they want us to find R. Well, we know that C has to equal 2 pi R as well. So if I have 28 pi is equal to 2 pi R, I can divide both sides by pi. Since it's just a number, it'll just cancel itself out. And we get 28 is equal to 2R, and then divide both sides by 2, and R is going to equal 14 inches, or centimeters in this case. But the pi's just cancel themselves out. It's just a little bit of algebra, nothing to be afraid of. Which means you should be able to do every last bit of classwork and homework in this section. So I know you're wondering what the classwork and homework is. We're only doing one section today, which should make you happy as well. Which means your classwork and homework isn't nearly as big as it was for the other one. So on page 469, the classwork is numbers 3, 7, 11, and 15. And then on page 469, the homework is numbers 5, 9, 13, and 17. All the answers to those are in the back. Aren't you happy? I will talk to you tomorrow, I hope.